Welcome to a new test and teardown video. I spent like 20 minutes or something like that trying to clean this up so it's a little bit presentable for the video. And I think I did quite a good job. So now it's alright to start playing with this thing. So it's a Philips PM5190 LF synthesizer. 1 millihertz to 2 megahertz. So it's a sine wave, square wave, and sawtooth, external AM. I think it can't do FM, right? So it's just a signal generator with super high frequency resolution, and it can read out voltage, AC peak, and then also DC offset. Okay, trigger TTL output. So I think we should just try and power it up, shouldn't we? Before and after cleaning. Look at the buttons here. Why do people use stuff with dirty fingers? So I cleaned those real nice. And can't we just once and for all agree on one thing? Don't put stickers on the front. See, I don't know if we can see it here. Stickers here, stickers here, stickers here. I think there was actually one more as well. But it's just impossible to clean up. So stop adding stickers to the front. Put it on the top right here. Before we power it up, let's have a little look at the back. So it's an X. So it's 47 watts, really? And I guess this is the screw for opening. And there's an IEC bus for remote control, and that was our external AM input. Means input is down here. I really don't like the cabled AC inputs. I prefer a connector, but that's just me. I think I'm ready to power it up. I really like those power switches. That's like opening here, and then you see this little white dot. But it's 50 watts of power consumption. We got no output, so I got no idea how to use this, but maybe it's frequency 1 kilohertz. No? How do you do this? And then what? Then we got output. But why is it this difficult? Okay, hertz 1000, frequency 1000, and then you push R for recall or some kind of stuff, I don't know. And yes, we got exactly 1000. So that's the TTL output. Okay, so how are we gonna get something out of the other output? How's that working? Well. I'm sorry, that took a little while. I needed to figure out how the heck the user interface is working. As you can see, there's a DC offset problem here. I guess if it's something to do with the settings. Look at that. It's a little bit unstable. AC. So how much AC you want? You hit this one, 0.5 enter, and then you got your AC. There's no error indications or whatever you're doing, so it can only do 1 volt maximum, I guess. Or else I don't know how to input more. See, if I put in 1.0, then I get 1.0, right? AC 1.2. Okay, good. AC 1.9. That will work. AC 2.0. And then I get nothing. So, okay, it can do AC 1.9. Fantastic. I got 0 in the middle, so it's DC here. 0.0, dude. And then it's not exactly like that. So that is what I think we need to play with. Minus. Okay, 0.5. See? So we are able to control the DC offset. And then now it's doing some blinkety blink. I don't know what it's trying to tell me. It's telling me that it's in crap mode. AC 0.5. I don't know. And then it stops blink. And then again, see? Unstable DC offset. So, I mean, okay, we got some stuff to look for. Let's try and open this thing. Gotta see this. This is some annoying way to open this instrument. You unscrew this and then you slide out the entire instrument to the front. But then it's stuck in the power cord. And that is a pain. See? Oh, this falls off as well. Oh dear. Okay, that helps a little bit. So then I pulled it back. Okay, that was the solution. Ooh, we got a little spider here. Another little pet. So we got 2 very large PCBs in here. And quite a lot of dust as well. So I need to clean this up. I had to try and do it like that. This so we can see, ooh, 77. So it's a good old one. A lot of read relays. I wonder what that is doing. It's a funny shield. Well, that's the power supply. All this is power supply. And 2 very big PCBs. Let's try and floppity flop here. Oh, that looks very different. Wow, look at the layout here. So they're doing the vertical, horizontal layout topology here. And they went all the way. And that means, okay, you can lay out anything you want on a 2-layer board with this idea. But in general, all the tracks, they're gonna be longest possible as well. Oh, look at that. They're gonna be long. But again, there's nothing in here that goes real fast. So how do you go in there in the middle? If you want to see all the components and stuff, I think this can be opened somehow because there's a plastic holder here. Ooh, that was good. I was not touching that. Look at that. So there's a flexible. Oh, that is neat. So there's a wire in here actually. Look. That is cute. That will be the entire front panel with all the interconnect to that. Let's see, there's a large IC here for all the interfacing and stuff for the front. So where is the DC offset? That's what I want to know. Oh, there's an input filter. Mains input filter right there. Okay. And a very beautiful mains transformer with ultra fine layers. I mean, that is amazing. They are so fine. And the way that this is assembled, perfectly straight. Somebody paid attention to detail here. That is nice. Now I'm going to figure out how to open this a little bit more. So in my quest to try and figure out how to disassemble this thing, I find something rather disturbing. Look at that one. And that pen on this IC. I mean, if I don't know any better, I would say they're touching. Let's try and get... Oh, they're not touching. Oi, that is close. But some dirty dust is actually touching, right? That can't be smart. Who figured that out? Obviously, this is designed before CAD, right? Or mechanical CAD. We didn't have 3D, assembly done on the computer or simulations like that. So they just try their very best, and then sometimes you have a screw or a nut in the middle of an IC and some stuff. Ay. But how do I... Because you see, I can't access the screws on those profiles because they're accessed from the front. And there we have the front panel. So how do I get this off? Let's go and get the manual, right? Let's see if we can debug this real fast for us, shall we? So what I'm doing is I'm monitoring the sine wave output, and I'm triggering where it's unstable, so I only see a shot of what is unstable. And then I monitor power supplies, first of all, just to see if there's any correlation on unstable power supply and unstable output. And that was not the case. Now I need to go and find the DC generator. So there's a DA converter and a DC generator system inside this unit. And it was super easy for me to find schematics. So that's great. Now let's figure this out. So far I went through all the DC offset stuff. This is the DC offset DA converter. Look at that. That's the output. And this is the sine wave from the DA converter. And that goes via this transistor to this output driver. And then we go to all the output attenuation stuff. So this is the constant signal or constant level from the DA converter, and then before it goes to the DC offset system. So far, as you can see here, super good and stable output. So that means this unit can be saved. Now I'll try and look at the other side of all those relays before it goes to the output stage. Because I know the output stage is going to be crap, because that is what we're looking at, right? So that's why I kind of, skipped a lot and then went here first. So I found the section of problems, as you can see here. And that is only the output stage. That's the problem. All the relays that handle the attenuations and all that stuff, the signal here on this point that goes to the amplifier, that's just absolutely fantastic, perfectly stable. And that means the input to the output stage is also nice and stable, as you see. So it's the output amp. And by the way, this one runs so hot. I mean, it's amazing, and all those those three are like really hot, and all this, I could probably cook something here. This is how hot it is. Well. So now we know the problem is the output amplifier. There's actually a little trick here. You can remove a soldering here, and that means you remove all the AC stuff to the output amplifier, and then you can only drive the output amplifier with the DC offset from this system. And this is just super perfect for figuring out exactly what is going on. So this op amp can now generate a positive and a negative signal on this side, and then you got a resistor to the input of the output amplifier. All you have to do is hit the plus minus DC offset here, and then the signal goes positive, negative, and then you can play around in your output amplifier stage. However, there's another trick for the lazy guys. Just look at the temperatures. So the burning hot transistors here, that's actually input stage. But look at that. One is a lot hotter than the other one, and the two next stages are ice cold. So that means no power is going through these, or there's no power dissipated in those, and you should actually expect all of them to be more or less the same, or I would actually expect them to be cold, medium, burning hot, or something like that, right? Because this signal goes this way out. So now it's going to be a lot easier to figure this out. I feel I'm almost done playing around with this unit. I kind of solved the output amplifier problem, and there's a funny thing about this DC coupled amplifier and the way that this is working. And the trim for DC input was open in one of the sides, so this one was hammering a lot of DC into the entire circuit. And for some funny reason, the way that the different transistors work here, they just go in a weird kind of off state because of that. And so, well, really weird. But so that was why I was fooling around in the wrong end, while it was just the input end. And by the way, the ultra low input impedance here is super low, so that means when you're measuring on the input, it's still 0 volts, more or less, but you just pull a little bit of current in here, and you can't really see it on the input, and then it affects the later stages, and the DC in the first stage is actually normal. So the next funny bug to find here is the different curve forms, or wave shapes. So look at this. This is sine wave. This is the triangle, right? So that works. Square wave, nothing. So I've actually started in the other end. This is the square wave system, and the output from the square wave is down here, and bada bing, bada boom. So that goes via some of those relays. That's the different waveforms, and this is of course the output attenuator, right? So now I know it's this relay, and I can measure the voltage on it, and I can actually also measure there's current going through this because of the way that it's controlled via those. So I know the coil is okay, but the read in here is there's no contact. So if I measure one side, see, nothing. And if I measure the other side, here's my signal. And of course, if I measure on the coil, yeah, see, one side of the coil plus 5 volts and the other side 0, or almost 0, like 100 millivolts. So this reveals current is going through the coil. But I don't have this type of relay. But I think if I remove the heatsink here and bend out the pins, I could actually pull out the read and change it. So I'm going to play a little bit of Frankenstein here and pull out the read from this one and see if that is a possibility, because I want to have this solved tonight and there's no other way. This is the kind of thing I do today or don't. And yes, no big surprise. This is of course a open close kind of relay, which is a little bit annoying. I can just use the close contact that I need, but a little bit annoying. But the size of the relay is exactly the same. So that was easy to pull this apart. I know this one works. And then the fun thing is, when I tried to remove the read from the defect one, it kind of fell apart. So it was broken. How the heck can this be broken? Did somebody throw this? You need to drop it on the floor. But anyway, yeah, it's completely broken. That explains why it's not working. Ah, crap and dead monkeys. Look at the problem. There's a diameter change or difference here, like a 0 point, I don't know what. But my new one here is a little bit thicker. So it's not going into that little shitty hole. And that means I am stuck for tonight. Oh no! I want this to work now. Not tomorrow. It looks like this is going to be the never-ending story. So, let's try and power this up again. Okay. This is the initial state. Now I've been reading the manual because I think there's some kind of a weird problem with this with the settings. It should be in frequency mode initially. So all I have to do is like 1, and then it blinks here, hertz, and then you hit hertz. Then you're done with that. But initially, of course, it starts up with 0, 0, nothing. So you need to hit AC button. It should be able to give you plus minus 19 volts. But I am just not able to recreate this. At least I have not figured out exactly what to do here. So what if I say 1, 0.0? Look at that. I can actually input 10 volts and then I hit aha. So now I know what the problem is. We have also a problem with the relay for the output attenuator, because I can actually set the output to 10 volts. But what I got here is, look at that. Nothing compared to that, right? Like I got 200 millivolts. So what kind of crap is that? But if I am in 200 millivolts per division, okay. So look at that. How do we prove the output attenuator is wrong? So if this is 10 volts, I hit output again and then I say 1.00. Are you looking at the scope? Ooh, then I get more. Haha. So there you have your proof, right? There's definitely something wrong with the output attenuator. It's that easy. So okay, let's do that again. AC 10.0. Okay, very little output. I should be able to do the same in DC offset mode. I should be able to say DC 1.0. Okay, now I got a DC offsets set of 1 volt and my output should be 10 volts. So this is 10%. And let's look at that. My output is a little bit higher like this, right? And also what you can see here, it's actually doing a little bit of slidey like that, right? So this tells me I got a leaky read relay somewhere, right? Because it's not stable. And if I measure on the output amplifier. It is rock steady. So there you have it. More of those fantastic reed relays I need to go and get. And then I can be done with this nice instrument. So I think I will close this video and just play with this the next few days because I need spare parts. So thank you very much for watching and see you again tomorrow. Bye bye.